at the practicalities of conducting this. You're doing a study. You start by writing a proposal. You will know your research problem, so you'll have your given exposure, your outcome. But you're doing a lot of literature to read and find out what are the other factors. What has previous knowledge shown us about the relationship between the exposure and the outcome? What is in the literature regarding other factors that may be related to this exposure or other factors that may be related to this outcome? So as you read your literature and you find these factors, you now mark them. You mark them. Any factor for which prior evidence indicates that it was a confounder, you mark that as a potential confounder in your own study. If you're doing a newer research area where there is very limited previous research, factors that are known to be associated with both the exposure that you're measuring and your disease under study or health condition under study, mark that one as a potential confounder. In addition, a factor that is known to be associated with the disease, but you're not too sure, but it may also be associated with the exposure, mark that as a possible confounder. So you have 3 levels of marking. As you read literature, you identify these factors. Either they've been known as potential confounders, they've exhibited confounding in previous studies, or they've shown potential confounding. If you're doubting, just outlist all of these factors and measure all of them. Prior knowledge of certain causal associations in the base population. I've mentioned this in literature search. Where do you find that? Literature review. So it's important before when you're doing a study is you do not do it blindly without a background knowledge of what has already been known about that exposure outcome association. You may also consider statistical associations, okay, as you look at the data. But it is important for me to mention now that do not rely purely on statistical tests to tell you whether a factor is a confounder or not. You have to use the biological plausibility. Plausibility should be used and not just the statistical tests. We've already mentioned the directed acyclic graphs, which I showed you earlier on. These help you to assess whether there was an exposure, an outcome, and what the relationship between this third factor was. Something like this. So these are the diagrams that we should be using to guide you to measure whether there is possible confounding. So we have looked at confounding assessment at the designing stage and implementation of the study, selecting participants and measuring. What about in the analysis? Now at the stage of analysis, again we have certain things to look at. One of them is we're going to do statistical analysis. So when we do stratified analysis, we're going to look at stratified analysis with the data. What we do is we now have our exposed groups, categories, and we have our outcomes measured in the 2 groups. One group was exposed, the other group was not exposed, and then we make our 2x2 tables. Exposed yes, exposed no, has outcome yes, has outcome no. We make our 2x2 table, and that will give us our measure of association. If it's a relative risk, it will number it. If it's an odds ratio, if it was a case control, we do that. Now, when we are going to do a stratified analysis, this one will be an overall. This measure of association, we call it a crude one because it is not split. Now, what we mean when we do stratified analysis is that we split. We now split by 2 categories of the possible confounder. If our exposure was drinking, alcohol drinking, and our outcome was oral cancer, but our potential confounder was smoking, we're going to have 2 tables of stratified analysis. We're going to stratify and make 2x2 tables. One of the tables will be among smokers, you make a 2x2 table like this. Among non-smokers, this is the second group of our potential confounder, we make another 2x2 table. So we have 2 of these tables, and we shall be able to find 2 odds ratio. One odds ratio among the smokers, the second odds ratio among the non-smokers. Remember, we also had the original table here, which before we split this drinking oral cancer group by smoking status, we just looked at odds ratio between drinking and oral cancer. So we have a third odds ratio. And what we mean here by stratified analysis is that we have split this odds ratio of drinking and oral cancer into 2. Among the smokers, what is the drinking oral cancer odds ratio? Among non-smokers, what is the drinking oral cancer odds ratio? And now we are going to do the comparison. We're going to compare the 2 odds ratios in the subgroups of smoking. And we ask ourselves, are these 2 odds ratios similar? Are they approximately the same? Then we are going to compare them. The second level, we compare them with this original overall odds ratio. And if the 2 are similar, but they are different from the overall odds ratio, then there is likely to be confounding. The 2 are similar, but they are different from this odds ratio, then there is likely to be confounding. That is our assessment for confounding at analysis of the data. If the other question is, if the 2 are similar, but they are also similar to this crude, the overall ratio. So we could have 3. These 2 small groups of smokers and non-smoker odds ratios may be similar, but may also be similar to this overall and split odds ratio. If that is the case, then our conclusion is there is no confounding. And in that case, we are now comfortable to report this odds ratio, the overall odds ratio. Should we find these 2 small odds ratios among the smokers and non-smokers to be similar but different from the crude, then we have to do adjustment. And that one we use what we call a Mantel-Haenszel adjusted odds ratio. What that one does is that it distributes the weights, the contribution of each group, and gives us an adjusted, I'll just use OMH as a Mantel-Haenszel odds ratio. It has a formula which will give us an odds ratio that is adjusted. And such an odds ratio will adjust for the confounding effect of smoking, so that our measure of association between drinking and oral cancer is adjusted for the effect of confounding, and therefore it has eliminated it or minimized it. So it is a more accurate measure than the original odds ratio, which we call crude, which did not cater for the effect of confounding. So that is stratified analysis. You split the 2x2 tables, you split the groups by the 3rd factor, which is your potential confounder. Now, the other thing you could do is you implement a matched design. Analysis of a matched design, once you did that in the matching, in the design of the study, and you matched cases to controls by the potential confounder, it could be age, it could be sex, then you're going to implement a matched analysis. Okay? By the way, if you didn't do a matched design, you cannot do a matched analysis. But you can only do a matched analysis if you matched in the design of your study. The other is to restrict during data analysis. You could say, let me restrict. These are statistical measures. The last one is model fitting. Model fitting is basically multiple logistic regression. Multiple regression methods. They could be logistic, they could be linear, they could be log linear, whichever they are. But the point is that they represent multiple stratified analyses. Usually in the demonstration here, we give one example of one confounder. So we're only looking at age. But in typical study, there are multiple factors that are actually potential confounders. So you'll find that you will have age, as a potential confounder, you have to adjust for it. You find that you have sex as a potential confounder, socio-economic status as a potential confounder, duration of illness as a potential confounder, HIV status can be a potential confounder, depending on what you're measuring. So you could have up to 5. Now, for each of these, to be able to adjust for them in using a stratified analysis, you're going to make like a 2x5 table. Remember that previously what I've demonstrated was just a 2x2 table for one potential confounder. So if there are 2 potential confounders, do a 2x2. A 2-way, they call them 2-way. If there are 3, you do a 3-way, a 4-way, or a 5-way table. And that one, what happens is that it becomes less convenient. It becomes more cumbersome. And now the more efficient method that replaces this multiple stratification is the regression models. That is the model fitting. So the model fitting is efficient, is that it gives you the same. This model fitting here gives you the same result as you would get with a multiple stratified analysis, but in a more efficient way. Because all you do is fit each and every potential confounder in the model. And that way, the results that you get will be adjusted for each of the factors that you put in as a potential confounder, and is more likely to be a more valid estimate. So we're going to briefly look at evaluation of confounding using the data. You've already collected the data. We've already mentioned about stratified analysis. And this is an example of a 2x2 table, whereby you are looking at male gender as a risk factor for malaria infection. You're interested in, is gender associated with malaria? And what we have here is a 2x2 table. We know that these are the males and these are the females. In other words, being male is our exposure. Being a female, therefore, becomes a non-exposure. The outcome will be malaria or no malaria. So the cases are the ones with malaria, the controls are the ones without malaria. So you measure your association 2x2 table, cross tabulation, and you get your odds ratio of 1.71. Okay? Now, this is a 2x2 table. We're now looking at a third factor. We have seen the association. At this stage, we conclude that yes, there is a relationship between being male and getting malaria infection. Because the odds ratio is above 1, it is 1.71. There is 71% higher risk of having malaria when you're a man compared to when you're a woman. So there is a relationship between being a male and getting malaria. Now, we want to look at the third potential factor, which is the kind of job that you do as an individual. The kind of job you do, if it is to be a possible potential confounder, we just ask 2 questions. Is the kind of job the individual does, is it related to being a man, which is the relation, which is the exposure? The same kind of job, is it, whether it is outdoor or indoor, is it related to getting malaria, which is the outcome? If answer is yes, then the kind of outdoor job, the kind of job that a person does, becomes a potential confounder. At this stage, we look at the data, we do the stratified analysis. Stratifying meaning subgrouping. So we've got 2 subsets. Subsets based on the third potential factor, the potential confounder. So our third set, this group, is among people with mostly indoor or outdoor, and then we're trying to assess, is the confounder associated with exposure? Is there a relationship between the confounder being outdoor or indoor and being male or female? In the second one, we are assessing, is the confounder associated with the outcome? Is being in an outdoor job linked to having malaria or not having malaria? Is being in an outdoor job linked to being male or being female? So we are assessing confounder exposure relationship, confounder outcome relationship. Okay? So we do the same 2x2 tables, and we get now our odds ratios. Our odds ratio, one of them is 7.8, the other one is 5.3, okay? And now we want to look at how do we compare? Is 5.3 approximately similar to 7.8? Because we said that we compare the two and find out, are these two similar? We commonly use the term homogeneous or homogeneity, meaning similarity. Are the two subgroups similar? If there is a relationship here, there is a relationship definitely here because the odds ratio is 7.8. Our conclusion here is that yes, being male increases your odds of working outdoors because the odds ratio is 7.8. It means the confounder is associated with the exposure. Being male, which is the exposure, is related to working outdoors. If you're male, you're 7.8 times more likely to be working outdoor than if you're a woman. You come down to here. Again, we're asking the question, confounder versus outcome. Is there a relationship between this potential confounder, which is being outdoor, and the outcome, which is malaria? So here we are comparing cases of malaria, controls of malaria, non-cases of malaria. And we are looking at mostly your work. Is your job mostly outdoor or not? And we realize the odds ratio is again 5.3. This tells us that there is actually a strong relationship between the outcome, having malaria, and having spending most of your day outdoor on an outdoor job. So in other words, these two split tables show us evaluation of confounding. We are seeing that this potential third factor, outdoor job, is related to our exposure being male because of this odds ratio. It is also related to our outcome, which is malaria, because of this odds ratio. Therefore, it is a possible confounder of the relationship between being male and getting malaria. Now we come to the level of stratification. We stratify. In this other slide, we were looking at evaluating the confounder. That's why we're looking at confounder and exposure, confounder and an outcome. And what is showing us, if this odds ratio was, for example, 1.1 or 1.0, and this odds ratio was also 1.0, it would mean that there is no relationship between this confounder and this exposure. And there is no relationship between this possible confounder and this outcome. It would actually mean that this factor is not a confounder. But the odds ratio of 7.8 and the odds ratio of 5.3 show us evidence that indeed outdoor job as a third factor is possibly a confounder between exposure being male and outcome having malaria. Therefore, now we go to the stratification. We are now dealing with the confounding at the stage of analysis of the data. We are looking at the confounding, at how we account for that possible relationship of confounding, so that our measure of exposure outcome is more accurate. It accounts for that third factor. So all we need to do here is to look and say, okay, what are the two split stratified analyses showing us? We know that in stratified analysis, which is stratification, we just subgroup. We subgroup by the level of a third factor. Here, our third factor is being outdoor in a job. It has two categories. It is either yes, you were in an outdoor, or no, you were not. Therefore, our strata are going to be two. The strata where the job was outdoor, and the strata where the job is not outdoor. If we had a confounder that has 3 levels, I'm thinking quickly of which example. I could have obesity or weight, either underweight or normal weight or overweight. Those are 3 categories. If that was my potential confounder, I would now split or stratify into 3 tables. I would have 3 tables here now. Right now, I have 2 because my third potential confounding variable has 2 categories. So we always split or we stratify our tables by the levels of our potential confounder. If there are 2, you're going to have 2 strata. If there are 3, you're going to have 3 strata. So in this case, our factor just has 2. So we have 2 stratified, 2 tables, 2 strata, 2 subgroups. One of them, we are examining the relationship between being male and having malaria in the subgroup or the stratum of people who are mostly working indoors. Sorry, mostly working outdoors. And then this lower table, we are looking at the same relationship, being male and having malaria within the group of people who are mostly working indoors. And then those are the 2 homogeneous strata. So we are going to compare and say, are these 2 similar? Now the first odds ratio is 1.06. The second one is 1.00, meaning they are almost similar. They are almost, the term we use in epidemiology is they are homogeneous, so there is homogeneity. What we're going to do next is we compare it. We compare it with our original table, which is right here. The one that looks at the overall effect. It is not splitting now by the level of outdoor job or indoor job, it is overall. That's why we call it the overall odds ratio, or the term we use most commonly is the unadjusted odds ratio. So there we have 2 stratum specific odds ratios. One was 1.06, the other is 1.00. And this one, the crude or the unadjusted one, is 1.17. It means the other 2 are almost similar, or they are homogeneous, but they are different from this crude one. And that one demonstrates presence of confounding. It means that this odds ratio is confounded. Why? Because it is different. It is different. So statistically or quantitatively, that is how we evaluate confounding using the data. We compare this crude odds ratio, which is the overall odds ratio before splitting into these 2 groups, and then we compare it with these 2 small subgroups. Here there is almost homogeneity, meaning these are almost similar. One odds ratio says 1.06, the other odds ratio says 1.00. These are approximately the same. But they are different from the other one, which means it's confounded. So what do? You do the Mantel-Haenszel adjusted ratio, which is what we said was the MH here. Mantel-Haenszel method of adjustment has a formula. So you do an OR, Mantel-Haenszel odds ratio, and you report that one. That will adjust for the confounding effect. Okay? So in other words, when you're looking at an exposure and an outcome, before you answer that yes, there's a relationship, the important thing to look at now is the relationship confounded?